Using single row functions. In this nugget, I'm going to introduce you to what functions are in general, and then how we can leverage the built-in function library that ships with Oracle Database 11g to extend the effectiveness of our SQL code. Specifically in this nugget, the exam objective calls for us to understand the basic character, number, and date functions that we can use in conjunction with select. Obviously, the exam objectives are covering just a small select subset of all available functions. However, by the end of this nugget, you'll at least know where to go in the Oracle documentation to learn about every possible built-in function. Let's get to work. As always, we need to understand basic terminology before we can start to apply that terminology in Oracle Database 11g. First of all, I apologize for the small font that you see here. Both of these definitions were borrowed from Wikipedia. I'll give you the links so you can easily look them up if you want to. We need to understand the distinction between the terms expression and function. Both of these have their origins in mathematics, but we're going to adapt these definitions to our work as database administrators. We've worked with expressions quite a bit thus far as we learned to extend our select statement, in particular using the where clause. According to Wikipedia, an expression is a finite combination of symbols that are well formed according to the rules applicable in the context at hand. Now, what does that mean in plain English? Well, we know that in the past we've used comparison operators like greater than, less than. We've used equals, less than or equal to, greater than or equal to do comparisons between column names and column values. We also learned the so-called Boolean operations. These are operations like and, or, not, like, in, between. A lot of these Boolean or so-called binary comparisons can be awfully useful in extending our code. Now, as I showed you how to use all of those different operators to build expressions, the notion of being well formed in Oracle terminology means that you're using them meaning the symbols, in a way that Oracle can correctly parse your query. And I'm not going to go over that. We've, over the last few nuggets, covered those rules of precedence, I think, very completely. Now then, a function, let's look at Wikipedia again, associates one quantity, the argument of the function, also known as the input, with another quantity, the value, also known as the output. A function assigns exactly one output to each input. Alright, now what does that mean as far as Oracle is concerned? Let's look in the lower right. I've taken the Wikipedia mathematics theoretical definition and tried to place it in a more appropriate context. A function in Oracle is compiled code. It's a compiled code module. You have your built-in functions or system functions that come with Oracle. Oracle has built these for us to save us a lot of work to do common things. Maybe case switches with character data. Perhaps we have algebraic, calculus, trigonometry that we need to do on number values. A lot of functions in the built-in function library allow us to do higher order mathematics, for instance. By contrast, we can also, if we want to, if we're of that bent, leverage procedural SQL or PLSQL to create what are called user-defined functions or UDFs. Now, UDFs are well beyond the scope of this exam in this nugget. In time, perhaps I'll create a CBT Nugget series to cover Oracle 11g development. If we do that, then obviously creating user-defined functions that suit your own business needs becomes relevant. Just for now, know that you have that capability. Alright? So the function represents the compiled code that can get you from point A to point B in your query faster than otherwise, right? Now, functions in most cases, but not all cases, require some kind of input or argument with which to do that work. For instance, you've probably used Microsoft Excel, right? Part of the Microsoft Office suite. Let's take a look at some of their functions just as an example. You might have used the average function in Excel, and the way you would write that function in that application is that you'd use equals, the name of the function, and then in parentheses you'd pass in one or more arguments that tell Excel what you're averaging. This could be a range of cells, it could be discrete values, whatever. So that's what an argument is. It gives the function some input with which to do its operation. Grist for the mill, as I sometimes like to say. The output of the function is going to be a single value. That's why functions are called scalar functions in some contexts. Microsoft, with their SQL Server function library, they tend to differentiate between scalar functions that return a single value and multi-value functions that return back a set. In this nugget, we're just dealing with scalar functions that you run the function, you get a single value as your output, and you go from there. Oracle terminology also draws the distinction between single row functions and aggregate functions. In this nugget, we're going to be focusing on single row functions only, simply because that's what the exam objective requires us to know. Single row functions are functions that operate on one row at a time. By contrast, an aggregate function will operate on multiple rows of data. You could take salary from all rows in an employee's table and come up with an average there, for instance. Single row, you're just getting a result for every row in that table that you're evaluating. Types of single row functions. In mathematics, you'll often see functions generically referred to as f sub x, f with x in parentheses. We now know that in this formulation, f refers to the function and x refers to the input argument. As we're going to learn in the upcoming demo, functions in Oracle work the same way. You have the function name and then optionally one or more arguments. Sometimes you'll see functions that don't involve an input parameter or an input argument as being given with just the function name with empty parentheses. What I've given you in this whiteboard is a laundry list of the basic varieties of single row functions in Oracle Database 11g. It's really not that complex. Some people are scared off by the idea of functions because perhaps they have some math anxiety, pretty common problem, and just automatically assume that functions are way over their head conceptually. First of all, we're thinking about the type of data on which we need to operate. Character data refers to alphanumeric strings. These could be first name, last name, department name, region, city, state, all these kinds of data types that we need to store in our tables that we're not going to do math on. That would be reserved for the number data type, wouldn't it? Three simple examples of functions that we're going to look at, all three of these in the upcoming demo, are lower, upper, and concat. And I'll give you a good example of just how simple using these functions can be. We might have last names stored in all uppercase in our base table, and we may need to take data from that table and use it elsewhere, maybe export it to a comma delimited file or for use with another line of business application. And let's just say we needed that last name column to be in lowercase instead of upper. Well, how are you going to do that? You could export the raw data from Oracle and then manually shift the case, but that's ridiculous. We can make use of the case switching functions built into Oracle, write our select statement, and instead of specifying select last name from employees, we would say select lower last name from employees. You see what I mean? So we invoke the function and then we can pass a column in as an argument. Functions are really nice because they're so flexible. You can run functions just alone against what's called the dual table. We'll learn more about that in just a moment. We can include functions in our select statements. The example I just gave you is an example of that. Functions are just so darn flexible. And especially, as I said earlier, once you get into learning PLSQL and developing your own functions to suit your own business needs, you can greatly enhance your productivity as a DBA as well as enhance the performance of your database. Upper takes lowercase or mixed case values and converts them all to uppercase. Concat is a way to concatenate or combine character strings. There's a few different ways that we can use concatenation. Very useful. A quick example would be, again, to use our employees table as an example, you might have a first name and a last name column. Chances are you're not going to combine names in a single column. That's not very flexible. But after your select, you might need a report that lists last name comma space first name. You can use concatenation function for that, or you can use a symbol that I'll show you in the upcoming demo to accomplish those kinds of goals. With regard to numeric data, remember, the key distinction in choosing a number data type for a column in your table is, am I going to do mathematics with that? Remember earlier I said if you were, for instance, storing social security numbers or credit card values, you would use a character data type for those columns to save space. Remember that there's more overhead involved with the numeric data types because you have the ability to do mathematics on them. So for space efficiency, you'll want to not use number but character for those. But things like salary, commission percentage, these sort of things lend themselves to a number data type. And we have a bunch of built-in functions that enable us to do useful things. Truncation, where you could take a number that involves plenty of precision and scale and just chop off basically everything after the right of the decimal point to give you an integer value. We have the round function, which does exactly what you think, rounds up or down depending upon decimal value. With regard to date data type, we have sysdate that can pull the current server's date and time from what's stored in BIOS. Months between, that can give you a number, the scalar value, as the number of months between a starting date and an ending date. These can be really useful again when you're doing salary projections, inventory reporting, etc. So to review, we have functions that operate on each data type. We defined data types in the context of variables in the previous nugget, but of course you have to keep in mind that every column in an Oracle table has a data type associated with it, and that the data type customizes or constrains the types of data, I guess that's why it's called a data type, that can be stored within those columns. Very common situation is what's called type casting or type conversion, where you, for instance, may need to generate a report using select, and you're starting with data in one data type, and you need to end up with the data in a different data type. For instance, you might have numeric values stored in a salary column, and you need to, after the fact, mark up those salaries with dollar signs and other graphical bling for the purposes of your report. One way to do this would be to, in your select statement, cast or change the data type of those retrieved rows, or those field values I should say, from number to say varchar 2. You can also work in reverse. You can start with character data that you need to perform mathematics on. Let's say you had a salary column defined in a table, and whoever designed the table did a really poor job and used varchar instead of number for that data type. You can use conversion functions in your select statement to convert that data type in the results and then perform mathematics on those results. Now, a couple points that we have to make clear. Remember, when we run select statements, you're not modifying any of the base table data. So if you have a poorly designed table with salary defined as varchar instead of number, and you run a select statement that includes a type conversion, well, that's going to affect the set result you get from the query, but not do anything to the base table. We have to think of what's called the pseudo column. Pseudo means fake or phony or artificial. A pseudo column is what you get when you invoke a function, whether it's a system function or a user-defined function, in your select statement. It's a column just like any other columns in your select column list, but it doesn't exist in the base table. That's why functions return what's called pseudo column data. Now, I'm getting kind of messy with all the blue on this whiteboard. The final thing I want to point out here is the distinction between implicit data type conversion and explicit. We're going to devote a separate whiteboard slide to this in just a moment, but for now, implicit means that Oracle takes care of the conversion itself. That is to say, as it parses your select statement, it looks and sees what you're trying to do with columns and their associated data types, and it will sometimes switch from one data type to another in order to meet your goal. For instance, you might have a select statement that pulls salary data that's currently formatted as varchar, and maybe you want to see that times 2. Well, you could include that expression in your select statement, and Oracle will implicitly convert the data type from varchar 2 to number in order to satisfy your query. Oracle's pretty good and pretty intelligent at doing implicit data type conversions. Oracle also gives us the ability as database administrators to perform explicit type conversions, and that's what is going to be shown to you on our next whiteboard slide. More about type conversions. Here I'm just showing you some examples of implicit and explicit conversions. Remember, implicit means that Oracle database, just as it parses your query, is going to intelligently parse your data types and perform type conversions to allow you to get your work done. For instance, date to varchar 2 is a possibility, number to varchar 2, or by contrast, you can work in reverse and Oracle can implicitly convert varchar or char to number or date. You'll see how that works in our upcoming demo. We also have a series of built-in system functions that enable us as database administrators to do explicit type conversions. Note that we have toChar, where we pass in numeric or date data types, and the end result is going to be character data. We have toNumber and toDate, which enable us to input a character column and come out with that data being formatted as number or date respectively. Again, remember that this process is formally called typecasting, and the notion of casting data types is not at all specific to Oracle Database. Remember, Oracle is an object relational database system, so it stores and shares data in a very similar way to any current programming language. Any development language you're bound to work with, from the scripting administrative languages like, say, Python, all the way up into Java and the .NET languages, you're dealing with typecasting all the time, so it's a very common thing to do. The final concept we have to cover before we do our demo is the dual table. This is something that when you first see it or see references to it in the Oracle documentation, you might be scratching your head thinking, what the heck is going on here? Especially those of you who are coming from, say, Microsoft SQL Server, which has no dual table at all. This is definitely a head scratcher. Here's the deal, friends. In Oracle Database, your select statements will always require a from clause, and I've drilled that into your head, I think, pretty well earlier in the course. Now, if you're a Microsoft SQL Server DBA, this rule is not anywhere near as so strictly enforced. You know that you can run selects against system functions by just using select and then the function name. You don't have to specify from. That's just implicitly handled by SQL Server. If you try to do that in Oracle, for instance, select sysdate, you're going to receive an ORA error because we need that from clause. It's just part of the adherence of Oracle Database to ANSI ISO SQL standard rules. We also recall that functions return pseudo columns. That's all well and good, and you can rename or alias those pseudo columns using the as keyword, as again we've previously discussed. Dual is a table that provides a target for system functions or just raw expressions. It's a built-in table that you definitely don't want to modify. Just let it go, leave it as is. It has, if you run a describe against it like we will in our upcoming demo, a single column called dummy that includes one row with one value, X. Now you don't want to monkey around with DML and try deleting the row. Don't get jiggy with it. Don't get funky. We just need to let dual exist. As simple as that. And as you'll see in the demo, you can run functions, user-defined functions, built-in functions all day long, and you specify from dual just to give yourself a dartboard, so to speak, or a target on which to throw those functions. We'll also see that we can do any kind of arithmetic or expression, again specifying dual as our target, and that data is stored only temporarily in the dual table. So in a sense, the dual table is somewhat like a temporary table. In this demonstration, we'll work with single row functions in Oracle Database 11g. As you see, we have our Nugget 5 script file up here, and I'm starting with some selects just to remind us we're logged in as HR, which tables we have in our schema, of course the HR tables from the Oracle sample schema set, and then we can run select star against some of those key tables. Just to let us know what's going on, you notice in row 10, our first example here where we start to use some of the built-in character functions we're pulling from the jobs table. To do that, let me run a select splat from jobs just so we can see what's going on. So you'll notice that job ID is stored in all uppercase, and job title, it looks like, is stored in what's called title case. Now, given that input, let's take a look at the select I've created for us. It looks like I'm going to show us the raw data from job ID, then we're going to cram job ID into the lower system function. Now, remember that SQL is case insensitive. The only reason I'm putting the function names in uppercase is just to make it easier for you to see and understand. That's all. So lower is going to take an input, character input, put it all in lowercase. A nitcap is similar to the title case, as I mentioned. Job title, and then we're going to take job title and put it all in uppercase from jobs. Let's run that query and take a look at the results. So as we can see, we have some virtual columns here. We have the job IDs put in lowercase and then a nitcap, job title in its original case, and then uppercase. You might be thinking, is this important? You'd be surprised, friends. You'll often need to pull data from your database table, and the source data is either in the wrong data type, or if it's character data, as I said, it may be in the wrong case. So I've found these character functions to be really, really useful, no doubt about it. Now then, remember the dual table, as I mentioned, is what we use as kind of our dartboard to throw functions against. If we run describe dual, we can see what I mentioned, that all there is a single column called dummy of the varchar2 data type, and notice that its length is 1 character. So let's for grins run the statement select dummy from dual, and we see that the 1 row's worth of data is just a single X. Now we can start to grab some system functions and throw those against the dual dartboard. User is a built-in system function that gives us our currently logged on user. Of course, no surprise there, it's HR. Sysdate, as I've previously mentioned, is a system function that can return at base the current date from the server. You can also run just standard expressions against dual, like I mentioned before. We could do select 2. We can run, say, select 2 plus 2 from dual, and we get that result back. Remember, aliasing is always helpful here. Let's rename that virtual column as sum here, rerun the query, and that can be nice for reporting purposes. In line 27, I'm taking another built-in system function, this one called length, and then passing in a string value, aliasing the column as length from dual. Now what does length do? The length is 14 characters. So basically with length you pass in character data and it will give you the number of characters that comprise that. Again, on its face, this might not seem particularly useful, but as your SQL code, in particular your procedural SQL code, becomes more complex, you may need to run evaluations against string data based on length, you see? So never underestimate the power of these things. I want to just take a pit stop. Let's open up a browser. I want to take you out into the Oracle website and their documentation, just so you know where to find all of these system functions. Now I've done a Google search for Oracle functions and come back with this page from the Oracle documentation library. This is from the Oracle Database SQL Language Reference for 11G Release 1. There's also a matching article for Release 2, but I think for our purposes here, Release 1 is fine. Now I'm going to give you a separate nugget on using the Oracle documentation, so I'm going to try not to reinvent the wheel here, but this particular article about SQL functions is going to be your go-to resource. In it, it covers a lot of what I've already taught you, differentiating the built-in SQL functions with user-defined functions that you can write yourself with PLSQL, and it gives you some see also links if you do want to read more about type conversion, user-defined functions, etc. It gives us the syntactical breakdown of the different types of functions. Remember, single row is just one type of, looks like 6 function types. There's the multi-row or aggregate functions, and then goes beyond that to much higher level functions that are beyond our scope. And then for single row functions, we're looking in this nugget at numeric character and date time functions, and then further down the page we get to the alphabetized list of those functions based on their type, you see? So you could just click the function name and it gives you a full breakdown of the syntax, purpose, and what I've always liked are examples that you can try to get a feel for different functions right off the top. Alright, so back to our regularly scheduled programming in Oracle SQL Developer. Let's come down to row 29 and run select splat against jobs just to see what's there again. Job ID, job title, we've done this, we've seen it. So let's proceed right to 31 where we're taking job title and then we're invoking the substring function in a couple of different ways. Notice that in this example the function has more than one input argument, doesn't it? Now what does substring do? Well, let me run the query first of all, and maybe you can tell just by context what's going on. Note in line 32, the substring job title 110, basically what you're doing is starting with the first position character and then displaying up to the nth position character. So in this case we're taking 10 characters, the first 10 characters worth of data from that job title column, and then the rest is just truncated complicated. Now this example, it's not all that useful, of course, because why are you going to use administra instead of administration vice president? But again, in cases where you do want to extract some data, because you may have, for instance, data stored in a very standardized way, such that maybe the job title has some kind of code, and then maybe an underscore, and then there's the meat and potatoes that you want to get to. You can use the substring function to start that extraction from, say, position 5, to get rid of the prefix and then just get the meat and potatoes of that field value, if that makes sense. Now, if we look at the second expression here, job title, comma, 11, this says start at position 11 and give me everything else. So again, it's not all that useful in this example. It clearly shows what's going on, but what are you going to do with, say, accountant instead of public accountant? You see what I'm saying? But certainly in this case that I gave you on 36, the substring function can be very helpful indeed. Moving on, another character function, inString. Look what we're doing here. Let's just run the query. We're retrieving the job title row, and then inString job title sales as sales occurrence. Remember, as is simply aliasing that virtual or pseudo column with a more human readable title. And what inString does is it takes as its input both the column that you're evaluating and some alphanumeric string, and asking the question, how many occurrences of that string exist in that target table? So in this case, sales manager occurs once, sales representative occurs 0, and then we have 0 occurrences of the rest of the columns. So to sum up, inString allows us to evaluate character data and return a number, interestingly enough, based on the number of hits on that keyword. So basically, this is telling us that we have 2 job titles that include the word sales. Simple as that. Now let's turn to concatenation. This is a very helpful function for pulling data out of your base tables and presenting it in a more user-friendly way. Now in 46, I've run select, concat, and passed in first name, comma, last name, and look at the result. Now that might not be as useful to you. Let me run a select with the column data in the raw, so to speak, just to show you what we're starting with. That in the employees table, we have employees' names broken out by first name and last name. And if in our results we want to see those names together in a full name, let's say, we could run the concat function passing in those names. And let's just alias this as full name and run the query one more time. Now again, in this specific case, concat function isn't all that useful in the raw here because, of course, we don't have a space between the names. They're just a single string. That's not all that useful, is it? If you're looking to have more control with concatenation, I find the double pipe operator to be much more useful. Different programming languages have their own concatenation symbols. Some use the plus, some use the ampersand. In Oracle SQL, we use the double pipe character. And before I show you what's on 51, let me run another select statement where we'll take first name, double pipe, last name from employees, just to kind of give you the comparison and contrast. You'll note that the results here are essentially the same as we received when we ran the concat function. So therefore, most folks, myself certainly included, take a more creative tack with the double pipe, and you can include what's called a string literal to make the concatenation look better. So if we look on 53, what's happening is we're selecting last name, we'll retrieve that first, space, double pipe, space, and then in single ticks or single quotations, we're including the string literal value, comma, space, and then we're again gluing that using double pipe to the first name column. And look what happens when we run the query. Last name, comma, space, first name, you see? So using the pipe symbol, the double pipe symbol, with string literals can be awfully useful. Another formulation here, let me modify this directly, is we might want to do select first underscore name, and let me just correct this before I forget, and instead of comma space, let's just do a string literal of a raw space. That should give us, as expected, first name, space, last name. And we might want to alias this to make it easier on the eyes. As full name, we'll run the query again. Beautiful. Let's move to numeric functions now. You'll recall I mentioned that the dual table is awfully useful when we're running ad hoc expressions and ad hoc functions, and we need to satisfy that requirement of Oracle SQL to specify a from clause. Here we're using pi, and we're first going to select the numeric literal value, and then for comparison, we're going to invoke the round statement a couple times, or the round function, I should say, and then we'll invoke the truncate function. Now, what does this look like? Let's run the query and I'll show you. All right, so first column, we have the literal number. Second column, we're rounding that literal, and then as the second argument, we specify the number of significant digits to the right of the decimal point. So in this case, we're rounding to 314.43. If we want just an integer, we can do round with 0. That gives us just the 314. And then truncation, as I mentioned in the theory part of this nugget, takes the input and basically chops off everything to the right of the decimal point. Now, what if we had 314.8? Is truncate going to round up to 314, or do you think the result will still be 14? Let's check it out. Still 14. So truncate just erases everything to the right of the decimal point. The example we have in line 66, a more complex example, is going to pull data from employees. We're going to bring back employee ID, first name, last name, salary column, and we're going to alias that as yearly. The reason why I'm doing that is, as you'll see, we're invoking the round function for our 5th column in our select results, where we need to see employees' monthly salary. What you're seeing here is a combination of nesting an expression inside of a function. You can actually nest functions as well if you want to do that. When you start nesting, just be especially careful of your use of parentheses. So on the outside of the round function, in our outer parentheses, we have first our input argument, which up to now has been either a raw number, a literal number, or it's been a column, comma, and then if there are additional arguments. Remember that round, we specify the number of decimal places to round to. So here we're going to round the salary column divided by 12. That's the inner parentheses. Remember, when in doubt, parentheses enable us to be as explicit as possible with Oracle to avoid ambiguity and confusion. Obviously, taking the yearly salary, dividing it by 12 gives you a monthly value. So we can run this query and we see yearly and monthly values. That can be useful. Of course, we can use order by if we want to do that, by either or both of those columns. In line 70, we have another more complex query. This gives a really cool example of the NVL function. The NVL function is used to replace a null value with a value. It could be a number, it could be a string. In this case, we're looking at the employee ID and commission percent columns. And then our third virtual column, we're invoking NVL, looking for nulls, and where we see nulls, we're going to replace with 0.2. Now, just for comparison purposes, let me run select against employee ID, just au natural, to see what's going on in that table. And you see, sure enough, there are quite a few employees who have nothing stored for commission and percent. Some do, but many don't. So NVL searches out those nulls and then replaces it with a target value. Now, you might be wondering, just looking at line 73, how does the NVL function know which column to evaluate? Well, that's where the where clause comes in. We're using where commission percent is null. So basically, you don't have to present a column here because the where is already filtering those appropriate rows. Let's run the query, and now we have for every employee whose commission and percent was formerly null, now listed as 0.2. Now, I'm not going to do it, but just take it on faith based on our previous discussions that if we run, in fact, why don't I do it? What the heck? Run the original query. Those nulls still exist in the base table. Our select is not actually making any changes to that base data. I know it sounds a little overly obvious to you, but I think it does bear repeating. 77, we're again embedding, in this case, one function within another. We're also embedding an expression. So there's quite a bit going on here. Let's take a look. First name, last name, job ID, hire date, and then we're developing a pseudo column called year's tenure. And that is going to, on the outside of the function, perform a 2 decimal place round. Within that round function, we're taking sysdate minus hire date divided by 365. So this takes today's date and then subtracts each employee's hire date to give the end result is the number of years that the employee has worked for the company. Now, it looks like we've got an extra column, an extra paren here, so let's get rid of that and run the query. So in running that query, again, keeping track of the parentheses can be kind of difficult. We've got a lot embedded. We come back with the employee's first name, last name, their job ID, their original hire date, and then the difference between the current today's date, which is June 17th, 2011, and their hire date, rounded to 2 decimal places. So it looks like Lex DeHaan, because we're ordering by year's tenure descending, has been with the company for the longest period of time. And then if we go down all the way to the bottom, it looks like Sundita Kumar and Amit Banda were hired on the same day. They have the lowest tenure, 3 years. I would say this company has a pretty good track record. I know a lot of other companies with much higher turnover rates. You probably do as well, right? Let's complete this demonstration with one more numeric function, and then we'll do some typecasting. Remember I mentioned that months between is useful, where we pass in a starting date, which would be here, and an ending date, which comes first, March 16th, 90, 22 May 1970. We'll run this against dual, and it's going to give us value. Now we could definitely do some embedding here if we want to round this. We can just enclose the whole expression in parentheses and then provide a number of decimal points. I won't in this case, but I hope you're thinking along those lines, the fact that you can embed or stack functions to further customize your output. And then 2 simple examples of data type conversion. We'll be working more with type conversions in line as we proceed through the rest of the course. But 2 simple examples: select toChar and select toDate. Now I'm not grabbing data from any base table, I'm just using literal values to show you what's up. Remember, toChar takes as its input a numeric type, in this case 1210.73, which is clearly, because we're not using the single quotation marks, a numeric data type. And we use string formatting conventions to determine what our output looks like. So in this case, we want to see $, comma, separator, and 2 decimal points, 2 decimal places. And sure enough, we do. And once you do that, you can operate upon that converted data however you want to in your code. You can also work with toDate, which is, again, the single quotations should tip you off that this data is coming in as character data. It looks like a date, sure enough, but it's coming in as character data, comma, and then you specify using an NLS date format. I know the single quotations might throw you off, but here with toDate, we're specifying using a date format how we want the date to come back. If we run that, now this data exists in these results anyway as the date data type. Using single row functions review. By now you should understand, number 1, the difference between an expression and a function. You should know the basic mechanics or syntactical rules governing the use of functions in Oracle database. And you should also have in your proverbial tool belt the basic character, number, and date functions that we can use with select, whether against one or more target tables or against the dual table to get your work done. I hope that this has been informative for you, and I'd like to thank you for viewing.